Hi, and welcome back to Go Digital Essay Foundation's Ithala Education Platform Advanced Pillar. I'm your instructor, Dave Semelink from Go Digital Essay Foundation. Today we're doing Unit 7, Machine Learning, Part 1 of 2. In the previous units, we looked at computers, coding, robots, and the Internet of Things. In Unit 7, we will look at machine learning, how a computer can learn certain tasks instead of having a programmer creating code to tell it how to do those tasks. So, what is machine learning? As we've seen, when you want a computer to perform a task, you can program the computer by giving it a set of instructions. The computer follows each instruction to perform the task. With machine learning, or ML, the computer is running a machine learning application. You tell the application what you want it to do by giving it a collection of example data that demonstrate how the task is typically done, and the application will use the examples to learn how to do the task. For example, if we want to get a computer to play chess, one way is to write a program with all the rules. But another way is with a computer running a machine learning application. You show the application a lot of chess games that people have already played, and it will learn the game. If you give it a limited number of games, it might not be very good at it. But if you give it more games, it gets better. Machine learning is a subset of artificial intelligence, or AI. AI was first imagined a long time ago, before computers even existed. People were interested in learning how we think and how we could make a machine appear to think. The earliest computers, starting in the 1950s, weren't powerful enough, that is, they were too slow and didn't have enough memory or storage to be very useful for AI. So AI was not applied to real-world tasks back then. But this changed by the 1990s as CPUs became faster and memory and storage grew. By 2015, artificial intelligence had become useful for many applications. AI needs very powerful computers. Cloud computing now gives everyone access to very powerful computers. AI is available in the cloud from these companies. Amazon Web Services is a cloud computing platform that is a subsidiary of Amazon. It was launched in 2006 and is currently one of the most popular cloud computing platforms for machine learning. AWS provides various products for machine learning, like Amazon SageMaker. This is used to create and train machine learning modules. Amazon Augmented AI. This is used to implement a human review of the machine learning models. Amazon Forecast. This uses machine learning to increase the forecast accuracy. Amazon Translate. This uses machine learning and natural language processing for language translation. Amazon Personalize. This creates personal recommendations in machine learning systems. AWS Deep Learning AMIs. This is used for deep learning solutions. And Amazon Poly. This is used to convert text into lifelike speech. Microsoft Azure is a cloud computing platform created by Microsoft. It was initially released in 2010 and is a popular cloud computing platform for machine learning and data analytics. Some of the Microsoft Azure products for machine learning are Microsoft Azure Cognitive Services. This provides smart cognitive services for applications. Microsoft Azure Databricks. This provides Apache Spark-based analytics. Microsoft Azure Bot Service. This provides smart and intelligent bot services that can be scaled. Microsoft Azure Cognitive Search. This is a machine learning-based service for mobile and web applications. And Microsoft Azure Machine Learning. This is used to create and deploy machine learning models in the cloud. Google Cloud is a cloud computing platform that is provided by Google. It was launched in 2008, and it provides the same infrastructure for companies that Google also uses in its internal products. Google Cloud provides various products for machine learning, such as Google Cloud Auto ML. This is used for training an Auto ML machine learning model and its development. Google Cloud AI Platform. This is used for creating, training, and managing ML models. Google Cloud Speech to Text. This is a speech recognition system for transmitting from speech to text, and it supports 120 languages. Google Cloud Vision AI. This is used to create machine learning models for cloud vision that detects text and so on. Google Cloud Text to Speech. This is a speech creation system for transmitting from text to speech. Google Cloud Natural Language. This is for natural language processing for analyzing and classifying text. IBM Cloud Platform is a cloud computing platform offered by IBM. It provides various cloud delivery models that are public, private, and hybrid models. IBM Cloud provides various products for machine learning, such as IBM Watson Studio. This is used to build machine learning and artificial intelligence models, as well as preparing and analyzing data. IBM Watson Speech to Text. This is a speech recognition system for converting speech and audio into written text. IBM Watson Text to Speech. This is a speech creation system for converting text into natural sounding audio. IBM Watson Natural Language Understanding. This is for natural language processing for analyzing and classifying text. IBM Watson Visual Recognition. This uses machine learning to search visual images and classify them. And IBM Watson Assistant. This is used for creating and managing virtual assistants. Many other companies use artificial intelligence. Tesla, the electric car company, is currently, that's in 2021, building the world's most powerful computer for AI. They plan to use it to train their cars to be better drivers than humans. They also say they are working on a human-like robot that will be able to assist you with your chores. So artificial intelligence is now an essential part of the fourth industrial revolution. The applications for artificial intelligence include artificial general intelligence, planning, computer vision, general game playing, knowledge reasoning, machine learning, natural language processing, and robotics. In this unit, we will use a machine learning service in the cloud. In the next unit, we will use a small machine learning processor. We start by training the machine learning application to recognize one or more groups of items. We then test it to see how well it works. Finally, we build an application in Scratch that uses the machine learning application. So the steps are train. You collect examples of what you want the computer to recognize. You learn and test. You use the examples to train the computer to recognize the text. And then we use the machine learning model you've trained to make a game or app in Scratch or in Python. And so we will be using Scratch. Let's say we want to tell a computer to turn a fan on and off. We could write a simple program that turns a fan on when you say fan on and turns it off when you say fan off. But there are many other ways to say that we want the fan on or off. So we tell our cloud machine learning application as many ways that we can think of. When we tell it to train using these phrases, it uses machine learning to learn what we want it to do. We can then make an application in Scratch where we can ask it in any way we like, and machine learning will try to work out what we mean. Note that the trained machine learning system doesn't only understand the exact phrases that you entered to train it. Training gives it a more general understanding of what is meant. Okay, so we'll see when we give it these phrases to turn the fan on, and we give it these phrases to turn the fan off. Then when we try to use the system, we'll see that we can use other phrases that we haven't entered here, and it uses machine learning to see if it's closer to these or if it's closer to these. And that will turn the fan on or turn the fan off. And of course, there's a third possibility that we have to get our application to use, and that is that it doesn't understand if it was fan on or fan off, and then it has to say, I don't understand. Okay, so let's try this now. We will use a browser to access the cloud computer, and we will use Scratch to make our application. Okay, so I've opened a browser, and I've gone to machinelearningforkids.co.uk. So if you type in machinelearningforkids.co.uk, it will take you to this welcome page. You'll see here, teach a computer to play a game, collect examples of things you want to be able to recognize, use the examples to train a computer to be able to recognize them, and make a game in Scratch that uses the computer's ability to recognize them. Okay, so I'm going to click on Get Started. Okay, if it's your first time here, you will have to register. Okay, I'm already registered, so I'm going to log in. You can also try it without registering, but that limits what you can do. Okay, so now I can go to my projects. There's also an admin page for managing my account, but I'm going to go to my projects. And I've created a few projects here, one called Make Me Happy and another one called Face Lock. Let's just quickly take a look at this one. Okay, so in this project, and in all the projects, we have these same three steps. We train, we learn and test, and we make. So I'll go into train. In train, you create groups. You're going to teach the machine learning system how to tell if something belongs in one group or another group. So I've created two groups. One's called kind things, the other one's called mean things. In the kind things, I've added these phrases. You're a lovely person. I appreciate all the things you do. Your hair looks great today. You're my best friend. I think you're amazing. Thanks for all your help. And that jacket really looks great on you. On the mean things, I've got you smell. I don't like you. You're as dumb as a bag of rocks. I'm fed up with you. You're an idiot. You smell bad. Okay, and here we can add more examples. I'll just add another one here. And for a kind thing, I can say, I really like you. Okay, so you can see that this has now been added to kind things. So why am I doing this? I want to write an application that's going to accept a phrase, and then it will tell you if what you're saying is kind or if it's mean. So now that we've got our examples, I can go back to the project, and now I can say learn and test. When I click on learn and test, the machine learning system will take these two groups of phrases, and it's going to teach itself what belongs in each group. Okay, and you can see here it says, what have you done? You have collected examples of text for a computer to use to recognize when text is kind things or mean things. You've collected 8 examples of kind things, 6 examples of mean things. So what's next? So ready to start the computer training, we click the button down here, train new machine learning model. And so that will start training a machine learning model using the examples we've collected. We can go back to the train page if we want to collect some more examples. Okay, so I'm going to click on this. And it does take some time for the machine to learn. Okay, so it says model started training at, and it shows the date and the time. The current status is training. So right now it's training. Okay, so if we want, we can cancel the training, or we just leave it until it's done. And now we can see it is done. So the next thing we can do is to test. So if I put in a phrase, it will tell me if it thinks it's a kind phrase or a mean phrase. So if I say, "You are pretty," it recognizes this as kind things. So it sees that this is more like the kind things than the mean things. And it's got 81% confidence. And this is important because we can decide that if it isn't very confident, we then say that we don't know if the phrase is kind or mean. I'll put in another one. "You are handsome." And it says this is kind things, and it's got 78% confidence. If I say "you are ugly," it recognizes this as a mean thing with 72% confidence. Let's say "you are big." Okay, it thinks this is a kind thing, but you can see it's now 62% confident. So it's not as confident as before because it's not sure. If you say "you are big," are you saying something kind or something mean? What if we put in something completely irrelevant? If I say "hello," thinks this might be a mean thing, but it's only 7% confident. So that's a very low level of confidence. So in this case, we would want our application to say, no, it doesn't know if this is mean or kind. Okay, so that's the training and testing phase. Now we can go back to our project, and we want to make. So we can make an application in Scratch, Python, or App Inventor. Okay, so let's try to use Scratch 3. Scratch, by the way, is a block programming language very similar to Make Code. Okay, and here it tells you that your project will add these blocks to Scratch. So it's extended Scratch with these blocks. The blocks that says recognize text and a box for the text. So you put text in the input for this, and it will return the label that your machine learning model recognizes it as. Another block is recognize text with confidence. This will return how confident your machine learning model is that it recognizes the type of text. And that will be a number from 0 to 100. So either 0% or 100% or somewhere in between. And we're going to label. These blocks represent the labels you've created in your project so that you can use their names in your script. So we can do a block program where we say ask, and we enter some text. So the person running the program will type in their text. And then if we recognize the text of the answer as one of the two labels, kind things or mean things, then you say, I think that was, and what the label is. Okay, so let's try this. So we'll open in Scratch 3. Okay, so here we've got our blocks. These are the blocks that were added by the machine learning system. So it recognizes text. Okay, so we have to start by allowing somebody to enter some text. These are the different types of blocks. So we've got motion, looks, which includes saying things, sounds, events, control, we've got our loops and conditionals, sensing, and we see here we've got ask, place to put in text, and it waits, and so on. Okay, so we know we need this. In Scratch, we need an event to start the app. So if I go back to events, we've got when the green flag is clicked. Okay, so when we want to start a program, we click this green flag and then it will start. It will ask something. So here we'll say something kind or mean. Okay, then we want to see if it was kind or mean. So we'll go to control. We'll use our if. Okay, we need to compare two things. So we'll go to operators and comparisons. So you want to see if something is equal to something. So now we go to our machine learning and we say, if we recognize, okay, when somebody types something in here, it comes in as a variable in answer. Answer is over here. So if we recognize the answer to this, and we want to see, is it equal to, go back to machine learning. If it's a kind thing, then we can say something. So we can say, thank you if it's kind. Now I can take all of this and duplicate it. And now we change it to mean things. So if the answer was a mean thing, then we say, that's not nice. Okay, so when the user clicks the green flag, it will ask him, say something kind or mean, and it waits. So he types in something kind or mean, and then it checks if that answer is a kind thing, then you say thank you. If that answer is a mean thing, then it says that's not nice. So let's try it. And we'll say, you are sweet. And it says thank you. Click the flag again. And we say, you are ugly. And it says, that's not nice. Okay, now if we put in something that doesn't work, like hello world, it doesn't know if this is kind or mean. Okay, it says that's not nice, but probably with a very low probability. Okay, so if we want to use confidence, this will return how confident it is. So before we check to see if it's kind or mean, we can check if the confidence is greater than, let's start at 70%. So if the confidence is greater than 70%, then we can check whether it's kind or mean. And otherwise, we say I don't understand. So let's try that. Let's say something kind or mean. You are nice. It says thank you. You are ugly. It says that's not nice. Now I say, hello world. It says I don't understand. Saying hello world isn't kind or mean. Okay, so that's an example. So let's quit from this. We can save this if we like. Okay, we should have given it a name, so it's saved as Scratch Project. We leave. Okay, so we can go back and now try our new project. Okay, so I'm back in projects. These are our machine learning projects. We're going to add a new project. We'll call this project Turn Fan On or Off. And this is, again, recognizing text. So we'll create the project. We'll open the project and we'll train. Okay, so we have no groups here, so we're going to add a new one. We'll call the first one Fan On. We'll call the next one fan off. Add an example. Turn fan on. Add another example. Please turn fan on. Or let's try something completely different. I'm hot. Okay, now if we want the fan off, we can say turn fan off. Please turn fan off. And I'm cold. Okay, so we've just got a few phrases here. So we can say, I'm sweating. And it's hot. Okay, so now we've got 5. Over here, we can say, I'm freezing. And it's hot. So now we get 5 of each. So now we learn and test. Okay, so now train new machine learning model. Okay, so the machine learning application is taking our 2 groups of phrases and deciding which is which. You'll see again, it takes a little time for it to finish training. When it's finished, this cancel training button will disappear and it will let us go on. Okay, it's gone. We can now test. So I can say, it's hot. And it recognizes this as fan off with 100% confidence, because that's exactly the same as one of our phrases. What if I say it's warm? It recognizes this as fan off with 99% confidence. Okay, this is not one of the phrases we put in. So how does it know that we want to turn the fan off? The machine learning application will have a dictionary of words, and so it knows that hot and warm are similar. Okay, so even though we never used the phrase it's warm, it knows that warm is not very different from hot, so it's put it in the fan off category. And again, we'll do something irrelevant. Hello. Okay, so now it says fan on, but that's with 11% confidence, which means it doesn't really know if it's fan on or fan off. Okay, so now let's make our application. We're going to make in Scratch It's made these blocks for us to use in our application. Okay, so now we know that we need an event to start. Okay, when you click the green flag, you want it to ask, what can I do for you? So you click the green flag and it asks, what can I do for you? And you can type in your answer there. So we're going to need to use the answer. So we'll say if we recognize the answer as fan on, then it's going to turn on the fan. Okay, we'll just get it to say that it's going to turn on the fan. Okay, then we can take this whole thing and duplicate it. If we recognize it as fan off, then we say fan turned off. So let's try this. What can I do for you? Fan on. So the fan turned on. Fan off. Fan turned off. It was it's getting hot. Now, this is not exactly the same as any phrase we've entered, but it realizes that we want to turn the fan off. Okay, and as we saw with our previous example, we should probably check and check the confidence. And let's say we want the answer to be at least 70%. So if it's more than 70%, it will check to see if it's fan on or fan off. But otherwise, we can say, I don't understand. Okay, so now when we try this, we can say, I'm cool. I'm cold. Fan turned off. I'm shivering. Okay, so it says I don't understand. So if we say I'm shivering, it doesn't understand that I'm cold. Okay, so the confidence was less than 70%. Now we can go back to our machine learning model and give it more phrases. There's a lot of ways to say that you're cold or you're hot. And the more you give it, the more it will be able to understand. Okay, so that's a simple example of machine learning with text. Again, we can save this to the computer. Okay, let's try a different project. Okay, let's create a new project, this time with images. So under recognizes, instead of text, it's going to be images. So we'll open up this project. We'll train it. Okay, I'm going to add a new label. So we're going to put in images of someone's face that we want to recognize. So I'm going to just call this faces. Okay, so I've got to drop pictures in here of someone's face. It should be the same person. We want to be able to recognize photos of this person. So I've looked up someone famous. And let's see if we can train it to recognize this face. Okay, I'm just grabbing photos. It says it doesn't support GIF images. It's only JPEG and PNG. Okay, that should be enough. Let's hope. So we want to train the system to recognize this face. So we'll go back to the project, learn and test. Okay, so now we've got 12 examples of faces. There is a problem here. it's asking if this is the only thing we want the computer to be able to recognize. And in this case, it's yes. We only want to recognize if it's this person. Okay, but so now we need to do some other work. We need to make another group that shows things that are not that person. Okay, so they suggest making a group called not faces. So I'll go back into train. I'll create a new group, call it not faces. And so we'll have to add faces of people who are not this person. So I'm just grabbing random photos of people who are not this person. Okay, let's hope that it's happy now. Okay, so we've got to get it to learn, and then we'll test it. Okay, so we're going to click Train New Machine Learning Model. And this could take some time. Machine learning with images and with sound will generally take longer than machine learning with text. Okay, let's try it now. Okay, I need to put in a link address for an image. I'm going to try this. Okay, so I've taken a photo that is not of this person, and it says that it is not in the group not faces with 97% confidence. So it definitely doesn't recognize them. Now let's try an image that is that person. And it says with 90% confidence that it is that person. Okay, so now that we've trained the model, we can go back and make an application. So we go to Make. We'll do this in Scratch. you'll see that the project will add recognizing image and the confidence and the label. Okay, so let's try it. Okay, so it's similar as before. We need to click the flag. In Scratch, we deal with these characters, which are called sprites, and we can change the costumes of the sprites by going to Costumes. And now we can upload costumes, which in our case are going to be images. So I'm going to take this, face 1, upload the next one, face 2, face 3, face 4, face 5, face 6, okay, and so the code we write is for this sprite. If I go to looks, I can say switch costume to and pick a costume, or I can simply say next costume. So if I take that, now each time I click on the green flag, it will go to the next costume for this sprite. So we got this one, this, 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 this. Okay, so now we want to compare these images with the ones that we taught the system to use. So we want to try to recognize images. You can say control, we're going to see what the confidence is. So we're going to check to see if the confidence is over a certain level. The image is going to be the costume. So if it recognizes the image with a confidence greater than, we'll start with 50%, then we'll check it. I'll say if the image, which is the costume, is equal to our group faces, then let's say okay, this is her. Duplicate that and say if that image is in the group not faces, then we just need to say this is not her. And finally, if the confidence is below 50, then we can say I can't tell. Okay, so every time we click on the flag, it's going to switch to the next costume. Then it's going to go to the machine learning system. We'll first check to see if the confidence is greater than 50. If it is, then if it's equal to faces, then we'll say that's her. If it's equal to not faces, it will say that's not her. If it's below 50, it'll say I can't tell. So we look over here, click the flag, it says this is not her. This is her. Uh-oh, this one says this is not her, but this actually is her. We might need to increase the confidence level. And again, this one, it says this is her. And this is not her. And of course, this is not her. Okay, let's change the confidence. Let's make this 70. It still thinks this is her. It's interesting. This is not her. This is her. Okay, now this says I can't tell. So it's having problems with this image. So it can't tell, but its confidence is below 70%. It still thinks that is her. Okay, so the system isn't very good, and to improve the quality, what do we need to do? If we go into train, we need to add more images. Okay, the more images we've got, the better it's going to work. Okay, so that's machine learning with images. I'm going to save this. I'll call it faces. Okay, so this has been an introduction to machine learning. In part 2, we will use a small machine learning processor with a camera and a display that will let us make a smart robot. So I'll see you then.